Welcome, this is lesson 9 of Unit 3 on polynomials, graphing factorable polynomial functions. It says to use a graphing calculator. Since we are so limited in our graphing calculators, I just want to show you how you could do this. If we know that y equals 0 on the x-axis, then you can set each of the factors to 0. This would equal 0 when x is 1. So you know it's going to cross at 1. This would equal 0 when x is 2, cross at 2. This would equal 0 when x is at 3. And this would equal 0 when x is at 4. Now the other thing that I'd like you to do is figure out, well, what degree would this be? Our leading coefficient is going to be x times x to the second, times x to the third, times x, which would be x to the fourth. So it's a fourth degree. Okay, you can just take all of your variable exponents and add them together when they're being multiplied. So x to the fourth. Now that doesn't tell you what the whole polynomial is, but it tells you that it's even because it's a fourth degree. Since it's even, we think end behavior. Next thing we look at, would it be a positive x to the fourth? Yes, it would. So it's even and it's positive. Remember, the positive end behavior was up and up. Now, you're going to have to, without a graphing calculator, you're going to have to just say, well, this would come down here to some extent. You can just dash it to kind of show, hey, I'm not looking at it on a calculator. This would have to come up, back down, and back up. When you come to class, grab a calculator and see how close you were on your little graph. Okay, next one. We have a square right here. So that is an x squared times an x would be x to the third, and times an x would be x to the fourth again. So we have x to the fourth, that's even, and that's positive. There's no negatives out front or anything or in those x's. So now we look at where our zeros would be. X minus 1, what would it be to equal 0? It would be positive 1. X and negative 2 would be positive 2. What makes negative 3 to 0 would be positive 3. Now here's the interesting thing. You know it's even, so you know that it goes this way. But we have no way, if we went down below here, to make it work out. It would be going down. Do you see what I'm saying? What changed is this. We squared that. Anytime you have an even number of times that something is a 0, which this is x equals 1 is a 0, and it's an even number of times, then we say that it goes tangent to the x-axis. Tangent means barely touching, didn't draw it right, like you'll have a circle and a line will come by and just barely touch it. That's tangent. So this, because it occurs twice up here, is just tangent. It just touches the x-axis. Now we can curve it back and go like that. Okay? So now we come down to this one. Now this is an odd number of times. Okay? So this one is an even, or this one is an odd as well. But we know that it's going to be fourth degree because x to the third times x to the first, that's fourth degree. And even, positive. So we know our end behaviors. We have x minus 1 would be 1 when it's 0. X minus 2 would be 2 when it's 0. And we know that this one needs to go through because it's to the first degree. So that would help us to conclude, what does this one need to do? Don't know how it looks in between. You can dash that if you want, but it's got to go through in some way. Okay? Only the evens go tangent. The odds, the 1, the 3, they'll go through. Okay, and the last one, this is x to the 4th, and it's right at 1. So again, we're going to end up with a tangent because it's even. We can't tell if it's even by 2, 4, 6, or what, so we just draw that going up. Okay? What are the zeros of the function? For f of x, the zeros are 1, 2, 3, 4. For g of x, just look at where it crossed the zeros. It was 1, 2, 3. For c, it was 1, 2. For d, it was 1. How many times does each zero occur in the factorization? Well, for this one, for f of x, it occurs 1 time for each of them. 1 time. For this one, see how the 1 occurs twice? So they put 1 as 2 times, then 2 and 3 is 1 time. Down here, 1 is 3 times. And 2 is 1 time. And then this one, the 1, is 4 times. That's how many times they occur if we expanded it out. At which zeros does the graph cross the x-axis? On this one, it's at each one, so 1, 2, 3, 4. On this one, g of x, it only crosses at 2 and 3. Here, on c, it crosses at 1 and 2. And on d, none. Now it says, when does it become tangent? On a, there were none. But on g of x, there was this one that was tangent. So 1. On h of x, there were none. We went through both times. And on d of x, there's 1. Okay? That's just looking at the tangents and the number of times it crosses. So now the question on this is, based on your results under a generalization about the number of times a zero occurs in the factorization of a function, and whether the graph of the function crosses or is tangent to the x-axis at that zero. So the generalization would be, if it's an even number of times the factorization occurs, then it's tangent. If it's an odd number of times the factorization occurs, then it's going through it. It's intersecting completely through the line. But it turns around and is tangent when it's an even. Okay, sketch the graph of x plus 2 squared, x plus 1, x minus 2, and x minus 3. They're going to step us through it. First off, the degree of the polynomial, sums of the degrees of the factors. So the degree of f of x is, well, we have x squared there, times x would be x cubed, times x would be x to the 4th, times x would be x to the 5th. So it is a 5th degree Okay, the leading coefficient is positive because all of these are positive. So it's a positive 1. That's just if we took all of our firsts there and multiplied them. Because the degree is odd and the leading coefficient is positive, think about odd and positive. And we know that it's the muscle man going up on that side, down on that side. So as f of x approaches, the x is approaching infinity. So if we're going this way, f of x is doing what? If you say positive infinity, you're right. And then when f of x is going towards negative, x is going towards negative, going out this way. Describe the behavior of the zeros. Okay? The zeros of the function are, go back up here. When will this become 0? When it's at -2. This would become 0 at -1. That would become 0 at +2. That would become 0 at 3. Okay. Identify how many times each 0 occurs in the factorization. The -2 occurs twice. So -2 is twice. -1, 2, and 3 all are one time. That just comes from how high of degree they are in their binomial. Determine the zeros at which the graph crosses the x-axis. Well, it crosses at -1, 2, and 3 because those are odd. Determine the zeros at which the graph is tangent. That would be at -2. Now they say sketch the graph. So we go -2. We're going to be tangent. Now it might go to the other side. You never know. So it could be one side or the other. At -1, and at 3. Now we can put in our end behavior. You know, this goes up. No, that's at our end, so it goes down. We can erase the upper one. And now we just kind of have to connect. Oh, I forgot the 2. There's what's going on. So it's at -2, at -1, at 2, and at 3. See, I knew that something was happening because I didn't have it matching up for the S. And there's the rough S. Again, that's not accurate except for on the zeros and the end behavior. That's how I'd like you to sketch. Can you determine how many times a zero occurs in the factorization of a polynomial just by looking at the graph? The answer to that would be no. You can tell that it's even if it's got a tangent. And you could tell that it's odd if it goes through. Super important. That's a great final exam question. Okay. Rational zero theorem simply says this, that if you take your leading coefficient, this leading coefficient right here, and it's a 1, and you take your constant, and you find their factors, the factors for the constant, put them on top of those for the leading coefficient. So for example, in that, 24 could be plus or minus 24 over 1, plus or minus 12 over 1, plus or minus 2 over 1, plus or minus 8 over 1, plus or minus 3 over 1, plus or minus 6 over 1, plus or minus 4 over 1. These are all the possible zeros for that function. Okay. Now, if c over b is a rational zero of the polynomial function, explain why bx minus c must be a factor. Well, I think I said b over c. I meant c over b. In other words, how we get this rational zero theorem. If this is a factor, then that means that if we plug it in, it would equal 0. Okay, we just discovered that on factors. That also means that x minus c over b equals 0. That means that x equals c over b. Now we get the c alone. Bx equals c, because we're going to bring it back across with the x. This means bx minus c equals 0. And that means that that's a factor. It equals 0, and when we plug it in, c over b, we get this. Okay? That's why it works. So now we're going to practice them. These get a little bit tedious, but you can do the math and know that you can. Okay, so use the rational zeros theorem. We take our constant and we take our integer in front of the leading term. So the leading term coefficient is 1. The integer factors of the leading coefficient are plus or minus 1. Those are the only factors for that. Now on 12, the factors were 1, 2, 3, 4, 5, or 3, 4, 6, and 12. Now the possible rational zeros would be all of these factors of 12 over this factor. But putting these over 1 doesn't change their values. So we're just going to put the plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay? Use synthetic substitution to test. It doesn't matter which one you start with. I usually just start with a couple low ones to see if I can get something to go in. I always try 1 because it's pretty sweet to do. So from this polynomial, we had our coefficients 1, -1, 8, and 12. We've already put them at the top here, 1, -1, 8, and 12, -8 and 12. And now let's try 1. We're trying to find a remainder of 0, remember? That's our goal. 1 times 1 is 1. 0, 1 times 0 is 0. -8, 1 times -8 is -8. And that would leave a remainder of 4. That's not what we wanted. Let's see if I can think of another one. Just go down the list. I'll try all the positives, then if I don't get it, then I'll try all of these as negatives. So let's try 2. Drop the 1 down. 2 times 1 is 2. 2 plus -1 would be 1. 2 times 1 is 2. -8 and 2 is -6. 2 times -6 is -12. Bingo. That one works. So now I found one factor. So 2 is a 0. That means that x minus 2 is a factor. Okay? Now we can use the results to write these as a product. So x minus 2 times, we always go 1 less, it was x cubed, so we're going to go x squared plus x minus 6. Okay? Factor the quadratic factor to write f of x as a product of linear factors. So take this and just factor it. Play the x game. X squared plus x minus 6. This is a 1 at the top, -6 at the bottom. Think of your factors. If you said plus 3 minus 2, you are correct. So we would go x minus 2, x plus 3, and x minus 2. Those are our factors. Now we use the factorization to identify the other zeros. So we have zeros at 2 from the original that we talked about a minute ago, -3, and 2. They cross 2 twice, -3 1 time. Determine the end behavior. Well, our polynomial is a positive cubic, so our end behavior should go up this way and down that way. So as x goes to positive infinity, y should be going to positive infinity. as x goes to negative infinity, y should be going negative infinity. And now we just go ahead and find our points at 2, at negative 3, and at 2 again. So we know that it's tangent here. We know that it crosses here. And we aren't sure of the loop in between, but we have an idea of how it might look. Okay? How did you determine where the graph crosses the x-axis and where it is tangent? Remember, if its factor occurs twice or 4 times or any even number, then it's tangent. If it crosses, then it means that it's only occurred an odd number of times. Okay? You fill these in, you need to be writing these. How did factoring polynomials help you graph the function? Well, in order to find the zeros, we had to factor it down to the zeros. Okay, how did using the rational zero theorem to find 1 0 help you find the other zeros? Well, once we found 1 0 and we got it to work, then we got down to where it's an x squared and we can factor it. Make sure to write that down and explain it to yourself. We'll do practice in class.